Okay, let me share my screen. Oh, you caught that. Okay. Well, welcome to the July meeting of the San Diego Astronomy Association. You know, we've got a great tonight. Our guest speaker is Dr., if I can say Dean, Ahmad, who is the founder and CEO of the Minaret of Freedom Institute, and he has a PhD in astronomy. So the subject is Signs in the Heaven, a Muslim astronomer's perspective on religion and science. And the extract that I have as a visual is, obviously I can't read it, but you notice the geometric patterns here. It's called the Tusi couple. And this illustrates the fact that everyone was having trouble with Ptolemy's Almagest and the whole notion of the mathematical complexity and maybe the illogic of it, a need for simplicity. And it's all of this type of information that was coming from the classical Arab astronomers, or Islamic astronomers, probably a better way to say it, did inform, Copernicus and some of the Western astronomers that we're familiar with. And this is a part of our education that we don't know, and I'm looking forward to learning more about it. Won't go forward. Come on. Somebody always has trouble. Just a little bit about the calendar. We have a star party at West Sycamore. ASIG is back. They've already had one meeting. I missed it, but David Wood conducted it, and we're going to start back with our imaging sessions again. A fairly robust star party schedule. Note that the Julian Starfest, and I've got a slide about that, is the 11th to the 13th. Anybody who can volunteer to help out, keep this thing going, we certainly look forward to having you. And if you've ever been to a star party that we hold for the SPIE, that's the International Society of Optics and Photonics, down at the Convention Center, not a very good place for a star party, but sure is fun because you'll meet, astronomers and opticians from all over the world. And they certainly enjoy looking through our telescopes and having the munchies. Julian Starfest again, these are the dates. You can see the list of activities and the schedules. There is a tour of Mount Laguna Observatory. I don't know if it's full at this point. Can anybody talk to that? No, but there will be food and beverages, lectures and so forth, and the great public star party on Saturday night. And please note that volunteers will have the opportunity to camp early beginning August 10th.
Ken, Dave here. Can you hear me?
Yes, I can hear you.
I spoke with Bill Cecil. I believe that the Palomar event is full right now. And so unless there's some openings or whatever, I think that's what we have.
Got it. They're going to Mount Laguna.
The Laguna tour, I'm sorry.
That's okay. We were at Palomar. We're all surprised that they wanted to go to Laguna again, but they're very nice people.
Okay, thanks.
Thank you. I like to pick out some astronomy news that maybe we haven't heard. And boy, I've never heard of this particular group, the North American Nanohertz Observatory for Gravitational Waves, NanoGrav. They report the first independent evidence for very low frequency gravitational waves, almost like a wavy background. So these would be, rather than these fast gravitational waves or relatively fast gravitational waves, speed of light, ripple through space and time, these are ones that propagate slowly and probably interfere with each other. And if you can imagine, like the image, shows kind of a wavy background, but not a lot of amplitude, if amplitude works with the math necessary. They have been using pulsar timing pulsar timing between pairs of pulsars in very long time frame schedules, 11 and 12 and a half year data sets. And they finally have evidence in the 12 and a half year data set that this phenomenon actually exists. I encourage people to find out more about it, and have a quote from a team member and a professor of physics at Caltech. The effect of gravitational waves on the pulsars is extremely weak and hard to detect. I think that's why we're getting at the 11 and 12 year, but we build confidence in the findings over time as we collect more data. With that little bit of news, let me introduce Dr. Dean Ahmad. He is an internationally known interdisciplinary scientist of Palestinian descent, interestingly born at sea and raised in the US, and he is the author of Signs in the Heavens, a Muslim astronomer's perspective on religion and science. I'm holding up a copy of his book, which I got from Amazon. It's available and very interesting. And he's taught courses in Islamic religion, history and civilization and religion, science and freedom at Wesley Theological Seminary, and another course at American University. He's received numerous awards for public outreach, and he graduated cum laude with a bachelor's degree from Harvard and a PhD in astronomy and astrophysics from the University of Arizona. We're fortunate to have him tonight covering this very interesting and very relevant topic. I will turn the meeting over to Dr. Ahmad, but before I do, please hold questions until the end of the talk. But if you have an urgent question or think something needs further explanation, put it in the chat so that maybe it can be addressed immediately. But thank you very, very much for participating. And Dr. Ahmad, the floor is yours.
Thank you, Kim.
If I can get out.
In the name of God, the compassionate, the merciful, peace be upon you and the blessings of God. Thanks for the invitation. I'm going to be presenting highlights from my book, Signs in the Heavens, which Ken has graciously held up for you to see. If you want to learn more details, I encourage you to get a copy of the book. But the main theses of the book are how and why Islamic religious beliefs drove Muslim studies of astronomy and of science in general, and what Muslim astronomers did and how it influenced later Western science. Now, the most obvious influence marker of this influence that members of this organization would be familiar with are the incredibly large number of star names that are of Arabic origin. And of course, the reason for this is that during the Dark Ages, Europe lost touch pretty much with science and rediscovered it through the translation of Arabic works into Latin. And so most of the stars were known by the Arab names. For the Arabs, they were interested in astronomy even before Islam came, because the stars provided a means of navigation through the otherwise trackless desert. So astronomy as an aid to navigation was something that was known even during what the Muslims called the Age of Ignorance, before Islam was revealed in the 7th century. But once the Quran was revealed, and the Quran is the holy book of Islam, which Muslims believe to be the literal word, literally the word of God revealed to the Prophet Muhammad, peace be upon him. I want to make sure you understand when I say literally the word of God, I don't mean that the book is always literal. The book contains many metaphors and allegories. What I mean is that it was God speaking to Muhammad, and therefore his words. And the Quran urged Muslims to study the universe and the heavens closely. It said, search, look for flaws, and denied that they would find any. It assured them that they should look again because if they thought they saw a flaw, the flaw would be in their understanding, not in the design. Now, at first, Islamic science consisted of massive translation movement to acquire the knowledge of other peoples, the Greeks, the Hindus, the Persians. And yet very soon, Muslim scientists began to go beyond the translation into criticism and into the development of new theories, and eventually a whole new paradigm of how science should be done. This new paradigm is very important because that paradigm marked the transition from the ancient way of doing science to the modern method of doing science. To the ancients, science was a purely logical endeavor. Aristotle said, everything is what it is because it can be no other way. So to do science, all you need to do is start from some sound premises or axioms, and then by logic alone, you can come to a conclusion about what the universe is like. The Muslims quickly developed a different epistemology. The first great mind in this was an optician, Ibn al-Haytham, who in his study of vision came to a very different conclusion from the ancient Greeks. The ancient Greeks believed that that vision was analogous to touch, that the eyes sent out feelers that looked around and then gathered information into them. But Ibn al-Haytham did a whole bunch of experiments that showed this was not the case. And he realized two things. The first off was that it was the ambient light reflected off of objects going into the eyes that was causing the images. And number two, that the images were partly created by the mind and by the optical system within the eye that was integrating these impressions that were coming into the eye into a perception of objects. Now, Ibn al-Haytham was not an astronomer, but this method of of course, he did experimentation. And I'll give you one really incredible example of his experimentation. He developed an early and correct theory of rainbows. And he he believed that rainbows were caused by droplets of water in the atmosphere. And he proved this by taking a crystalline globe, filling it with water, and holding it up at different angles to the sunlight to duplicate the creation of the rainbow, thus proving experimentally his theory. Now, this method of doing science, which gets articulated much later by the philosopher Al-Ghazali, of whom I'll have much more to say, this method of doing science is an early draft of what we call the inductive method of science, which is the method that is used today and constitutes modern science. Not starting from axioms and coming to correct conclusions by logic alone, but by hypothesizing theories and then testing them and then revising them as the tests may show. Now, for astronomers, doing experiments is very difficult for obvious reasons. So astronomers depend more on observations than on experiments, but the principle is the same. What you want to do is you want to have a hypothesis or a theory, and then you want to test it by doing ever more careful experiments and examinations. And I can give you no better example of this in Islamic history than their disproof of Ptolemy's theory of precession, or actually of Ptolemy's measure of precession, and eventually of the theory of precession. Ptolemy had measured precession, but Ptolemy's measurements were not very precise. And yet, he had so much confidence in his measurements because he believed, as Aristotle said, everything is what it is and can be no other way. So once he measured precession, that must be the value. He believed so strongly that he knew the correct value that when he created his star atlas, he did not bother to look at the positions of the stars. He took an older atlas that was created by a previous Greek scientist and he corrected it for the precession in the intervening time. But because his measurement of precession was wrong, the correction was wrong, and the stars were not where he said they were. If he had just looked, he would have seen this, and he could have corrected his mistake. But he didn't look. Looking didn't seem to be that important to the Greeks. Thinking what was important, logic. Now, when the Muslims came around, they looked, and they were shocked to see that the stars were not where they should be, based on projecting precession from Ptolemy's day to their own. So how are they going to explain this? They created a hypothesis. The hypothesis was that the value of precession was not a constant, that it had changed since Ptolemy's time, that Ptolemy had the correct value, but it had changed in the meantime, and now it was something else. But they didn't stop. Again, challenged by God, look again. They kept looking, and they kept measuring the star positions, and they saw that the value of precession in their own time over the centuries was a constant. And they very reluctantly came to the conclusion that Ptolemy made an enormous mistake, and they couldn't understand how he made this mistake. Well, of course, he made it because of his epistemology. So that was the theory of precession. And it demonstrates how the difference between inductive science, where you just keep on looking, you keep measuring, you keep thinking of new ways to test theories. Now, evidence for the importance of astronomy in Islamic civilization can be seen from very early on. As I said, Islam came to the Arabs in the 7th century. As early as the 800s, Al-Ma'mun, the caliph, the secular head of the Muslim world, established large-scale instruments for the measurement of the position of stars, and they proliferated in the 10th century. Al-Tusi, in the 13th century, created the gigantic Meragha Observatory, which was a full-fledged research center. It had astronomers and scientists from all over the world. There wasn't even a Chinese astronomer on the staff. As late as the 15th century, Ulugh Beg established a large observatory, and in 1577, the Ottomans had one built in Istanbul. The high accuracy of the instruments throughout this period created a measurement so precise that they created a challenge to the existing theories. Well, just to give you one favorite example of mine, because he's an astronomer or scientist of such ability that one could argue that he was the greatest scientist who ever lived. His name is Al-Biruni, and Al-Biruni made a measurement of the Earth's circumference. He wasn't the first to do this. I'm sure you're all aware that Eratosthenes did it, and the Hindus had also done it by a similar method to Eratosthenes. What's interesting about Al-Biruni is the cleverness of the method he used. Eratosthenes, I'm sure you remember, noticed that on a certain day, the sun shone straight down a well in a certain village in Egypt. And knowing that the Earth is round, he measured the angle at which the sun departed from the perpendicular at a village 50 miles north of this well. And he figured, using pure logic, that the angle, the ratio of the number of degrees that the sun was off the perpendicular from the second village to 360 degrees would be the same as the ratio of 50 miles to the circumference of the Earth. And he came up with a number. We're not sure exactly how accurate the number is because his units were not miles, his units were stadia, and we're not sure exactly how long a stadium was. But for any reasonable assumption, it was probably a pretty good answer. He probably had it within 2%, which is not bad. Al-Biruni came up with a method that didn't require expeditions to go 50 miles the following year to another place, but a method by which a single astronomer could determine the circumference of the Earth in a single day. The first thing he did was to use simple trigonometry to measure the height of a nearby mountain. He then climbed to the top of the mountain and measured the angle dip of the horizon from the perpendicular. This obviously would be related to the circumference of the Earth, and would be related trigonometrically to the height of the mountain. But get this, he put in a correction for refraction. Now, this is really interesting. Of course, one might ask, well, how did he know what the correction for refraction was? He didn't know the index of refraction of the air. He didn't know the height of the atmosphere or any of that stuff. And the answer, I think, he didn't say, unfortunately, how he did it. But I think he did it because Muslims had been, of course, keeping track of the time of, say, sunset for prayers. And the sunset would not set exactly at the time that you would calculate by pure geometry because of the refraction of the atmosphere. So he knew that extra, the departure from pure trigonometry, from pure geometry, would be due to refraction by the air. Ibn al-Haytham had made measurements of refraction way back in his work on optics, so that was nothing new. But the fact that he put it in is interesting. And also what's interesting is this. After he gives his answer, which appears to be within 0.5% of the modern figure, he says that he believes that the ancient Hindus may have been more precise than his own, showing that he had some knowledge of the importance of theory of error. Now, it was not modern theory of error, which implies use of statistics, and statistics comes out of study of gambling, which the Muslims consider to be a bad thing. But nonetheless, he was aware that error is something that you have to take into account when you talk about these things and compare values. Another interesting thing about al-Biruni, that's al-Biruni as an observer. Now get this al-Biruni as a theoretician. Al-Biruni refuted the, let's not say refuted, that's too strong. He questioned the existing theories of gravitation. You may recall gravity in that time had been pretty much the same theory that Aristotle postulated for gravity, or the ancient Greeks postulated, that gravity is a tendency of heavy things to accumulate at the center of the universe. So the Earth-like elements, or the element Earth, as they would have it, clusters at the center of the universe. Slightly lighter element of water floats on top of it. The somewhat lighter element of air floats on top of that, and the lightest element of all of fire rises to the very top. Aristotle's theory seemed to be supported by the fact that the quintessence, the fifth element of the heavenly bodies, didn't want to go to the center at all, but wanted to go in circles around the center. Al-Biruni argued with his contemporaries about this. It is entirely possible, he said, that bodies other than the sublunar bodies have weight, that the quintessential elements have weight, but that something else prevents them from falling to Earth. Now, as a matter of fact, he was right. Later, Newton showed that the heavenly bodies like the moon actually do fall to the Earth, but the gravitational rate of their acceleration towards the Earth is offset by their inertial motion, so that they end up moving in ellipses. Al-Biruni did not come to that conclusion, but it's interesting that one of the scientists he argued with was Ibn Sina, who was doing work on inertia. One can only wonder if communication was more instantaneous in those days than it was, that they couldn't have compared notes and perhaps beaten Newton to the punch. Anyway, it's just interesting that Al-Biruni was not taking the rationalistic view that everything is what it is because there'd be no other way. Obviously, the heavenly bodies must have no weight because there's no other way you can explain their motions. And said, well, no, I think there may be other ways if we can figure out what it is that would hold them up, other than to counteract their tendency to fall by gravity. Well, this brings us to the big question, of course, how do planets move? And it is here more than anywhere else that the myth that religion and science are opposed to one another arises, primarily out of the Galileo affair. My thesis is that the Galileo affair, that this whole question is an accident of Western history, did not occur in the Muslim world, and that there was no opposition between religion and science in the Muslim world. Now, you will find, if you do a careful historical study, there was an argument between religion, revelation, let me say, and rationalism. But as I just said, rationalism was an ancient philosophy that is nothing to do with modern science. Modern science is not a monistic epistemology. It does not say that there's a single means of knowing what's true. It says that you have to interact. You have to have, yes, you use reason, but you also have to use your observations and your experiments. This idea that you needed multiple means of acquisition of knowledge fits in well, or is harmonious with the view in the religious sciences that in the Muslim view, it's not that reason is bad, it's that reason is incomplete. And just in the physical sciences, you have to do experiments and observation. In the religious sciences, you need revelation. But you should approach the revelation rationally and not come to irrational conclusions about what the revelation means. Well, I won't go too deeply into that because it's a bit off topic, but I just wanted to make the point because it'll come up again later when I talk about Al-Ghazali, that the idea that a monistic view of knowledge is untenable. So you can't rely just on reason to do your science, and you can't rely just on revelation to do your religion. You have to have an interaction. Okay, so what about then the motion of the planets? Why do I say that it's an accident of Western history that this was such a big deal? Well, it was clearly not such a big deal in the Muslim world. Al-Biruni, for example, discussed the question. He ultimately came down on the side of the geocentric position, and in particular of the immobility of the Earth. But he did so not for astronomical reasons and not for religious reasons. In fact, he said most pointedly, the solution as to whether the Earth goes around the sun or the sun goes around the Earth, as to whether the Earth turns or whether it is stationary, is not an astronomical and it is not a religious question. Because astronomically, the relative motions of the bodies will be the same whether the Earth is at the center or the sun is at the center. Whether the Earth is turning and the heavenly sphere is fixed, or whether the Earth is stationary and the heavenly sphere turns. You cannot decide this by astronomy alone, nor can you decide it by religion, because religion is indifferent. Religion is only concerned with the fact that whatever it is, it was God who created it, and God who decreed it would be that way, not which way it is. It is a question of physics. And it was because he accepted the Aristotelian physics that he had to believe the Earth was immobile, because if the Earth was turning, why didn't we fly off it? If you take a lazy Susan and you put some teacups on it and you spin it, what happens? The teacups go flying off. And yet we don't go flying off the Earth, so it would seem that the Earth must be stationary. Now, in fact, he was right that it was a question of physics, but he was wrong that the Earth doesn't turn because he was using the wrong physics. Aristotle's physics are wrong. Once you get Newtonian physics, then you can explain it, and it all becomes coherent. But that would come later. Let's stick to the question of how do the planets move. Now, since the Muslims generally did not accept the heliocentric theory, why were they so critical of Ptolemy? What was wrong with Ptolemy's theory? Well, a couple of things were wrong. The first and most obvious was it's so complicated. They wanted everything to be simple. I guess anticipating Occam's razor, if you have two ways of explaining something, the simple one is most likely to be the correct one. So this is where the Atusi couple that Kin showed us at the beginning of the before the lecture began becomes so important. Atusi found that he could duplicate Ptolemy's relative motions of the planets without the complicated system of epicycles and equants and all this, stuff that Ptolemy had done, by replacing the epicycles with the Atusi couple, which is as the diagram Kin showed, it's like a cylinder rolling within a cylinder. And he found that by using the Atusi couple, you actually eliminated the equant altogether. Now, for those of you who don't know what the equant is, when Ptolemy says that the sun goes around the Earth, he doesn't really mean that the sun goes around the Earth. He means that the sun goes around a center of motion which is offset from the position of the Earth by an amount called the equant. Similarly, if the moon goes around the Earth, and here we don't have any problem with with about relative motion. The moon does go around the Earth, but not in Ptolemy's theory. It goes not around the Earth, but it goes around a center of motion offset from the Earth by an equant, and so on for all the other planets. Atusi found that by using the Atusi couple, he got rid of the equant completely and therefore vastly simplified Ptolemy's theories. But his student, Ibn Shatter, went a step further. Again, look and test your theories. He said, why are we satisfied to have either Atusi or Ptolemy tell us where the planets are going to be if the size or brightness of the planets doesn't match? Take the moon. If the moon moved the way Ptolemy says it does, or as Atusi duplicating Ptolemy's results said it would, then the moon would be twice as big as it seems to be in the sky at a certain point than it really is. We should not be satisfied with the positions of the planets. We should also be able to predict their size, or in the case of the distant planets, their brightness. And bear in mind, the word for brightness was magnitude, same as size, okay? So the size. He found that if he complicated Atusi's theory slightly, instead of just having a single cylinder within a cylinder, but adding multiple cylinders until you got an exact match of the motions and sizes of the planets, that you could predict everything about the planetary motion, size and motion. And this theory of his, still geocentric, explains things beautifully. So beautifully that when you look at Copernicus's theories, you find that his motion, Copernicus's model, and Copernicus openly admits he's using the Atusi couple. He uses the phrase Atusi couple. But he's actually, without naming Ibn Shatter, he is duplicating Ibn Shatter's theory, because he did add additional, they call them epicycles, but additional cylinders beyond the two that Atusi used, to match Ibn Shatter's theory. He was presenting Ibn Shatter's theory when it came to the motions of the moon or the motion of Mercury around the sun. It is only when he's talking about the motions of the Earth and the sun that he's still using Ibn Shatter's model, but he has now switched the position of the Earth and sun, which is easy to do in Ibn Shatter's model. Very hard to do with Ptolemy's model. Remember, Ptolemy's model is so cumbersome that to do a simple switch is a major mathematical challenge. Whereas in Ibn Shatter's simple model, it's easy. It's just putting your pin on a different body and keeping all the other motions identical. So, the question was, when I submitted my draft of my first book, I submitted it to my mentor, Owen Gingerich, who is very knowledgeable in the history of science, not as much in Muslim science, but history of science in general. He's like the #1 guy. And he had a hard time accepting that Ibn Shatter had influenced Copernicus. Didn't deny the similarities of the models, but he thought it must be a coincidence. Why? Because Copernicus didn't know any Arabic. How could he have possibly been influenced by Ibn Shatter? And Ibn Shatter's models had never been translated into Latin. So where would Copernicus get this from? Fortunately, there's another great historian of science who I did not meet until I wrote my book, and that's E.S. Kennedy. And E.S. Kennedy does know more about Islamic science, its influence on the West. And he referred me to a book by Nordlow and I've forgotten now the name of the other author. But anyway, there was a book written by a couple of historians of science in which they said the question is not whether Copernicus was influenced by Ibn Shatter, but how. And their answer was Copernicus did not study astronomy in Poland nor in Germany because there were no good schools of astronomy in Poland and Germany. If you wanted to study astronomy, you went to Italy, where the University of Padua, which had been set up by a man named, his name was Constantine. He was a Christian, but he was from North Africa. And he had seen the Muslim universities in North Africa. And he wanted to set up a Muslim-style university in Italy. And so he went to Padua and took a medical school there and converted it into a full-fledged university. And at that university were teachers very knowledgeable in astronomy, all of whom were familiar with the works of Ibn Shatter. And they would have told Copernicus, and Copernicus, being a very smart guy, on the strength of their explanations, could have reconstructed the math to duplicate Ibn Shatter's models. So all of that raises the fascinating question of why is it then that the Muslim world is so backwards today? If it was the leading the whole world in science as it did for hundreds of years, what went wrong? Well, when I gave the talk at 2 weeks ago, a questioner in the audience said, what did I think of Pervez Hoodbhoy's theory? He's a Pakistani physicist who blames Al-Ghazali. He says it was Al-Ghazali's philosophical criticism of the rationalist philosophers that resulted in the decline of Muslim science. I do not accept that. As I said, Al-Ghazali articulated the new epistemology. He was critical of rationalism, but not of reason. That's a very sad misunderstanding of what he said, to think he somehow was against reason, or certainly even worse, to say that he was against science. Now, to demonstrate that Al-Ghazali was not against science, I ended up quoting, and at the other meeting I was quoting from memory, so I may have screwed up a little. This time I've got some passages in front of me. Here are some of the things Al-Ghazali said. Good thinking for an hour is better than divine service for 1 year. He who is indifferent to the sciences and he who is asleep are of the same rank. Just as it is not a condition of religion to reject medical science, so likewise the rejection of natural science is not one of its conditions, except that religion requires the recognition that nature is entirely subject to God, incapable of acting by itself. It is an instrument in the hand of the Creator. The sun, the moon, the stars, and the elements are subject to this command. Everything has got a weapon, and the weapon of the believer is his intellect. Everything has got a mainstay, and the mainstay of man is his intellect. Everything has got a support, and the support of religion is intellect. Every people have got a goal, and the goal of this people is intellect. Every people have got a mission, and the mission of this people is intellect. And then there is this passage. He who thinks it is religious duty to disbelieve such things as proven astronomical theories is really unjust to religion and weakens its cause. For these things have been established by astronomical and mathematical evidence which leave no room for doubt. If you tell a man who has studied such things so that he has sifted all the data relating to them, and is therefore in a position to forecast when a lunar or solar eclipse will take place, whether it'll be total or partial, and how long it will last, that these things are contrary to religion, your assertion will shake his faith in religion, not in these things. Greater harm is done to religion by an immethodical helper than by an enemy whose actions, however hostile, are yet regular. For as the proverb goes, a wise enemy is better than an ignorant friend. And then finally, oh, I'm sorry, no. The study of astronomy has no bearing on metaphysical investigation. For this is as if someone were to say that the knowledge of this house came to be through the work of a knowing, willing, living builder endowed with power, requires that one knows that the house is a hexagon or an octagon, and that one knows the number of its supporting frames and the number of its bricks, which is raving. Its falsity is obvious. Or that one does not know that this onion is temporally originated unless one knows the number of its seeds, all of which is an abandonment of rational discourse, discredited by every rational person. And finally, in the latter days, there will be ignorant worshipers and sinning learned men. Wow, that's scary. If that doesn't describe our time, I don't know what does. Anyway, so the point here is that Al-Ghazali was just criticizing rationalism. He was certainly not criticizing science. He was a big fan of science. And that therefore, there is, however, a kernel of truth in what Hoodboy says. And that kernel of truth is this. Among the people who misunderstood Al-Ghazali was not just anti-religious people. Many Muslims also misunderstood him and took his attack on rationalism to be an attack on science, which it was definitely not. But another thing associated with Al-Ghazali is his reconciliation of religion and mysticism. The religious jurists were always critical of mysticism in the same way they were critical of astrology. And that could be a problem, by the way, for astronomy, because as you know, in ancient times, astronomy and astrology were pretty much intertwined. Al-Ghazali was pretty good at pointing out what the difference is, but his readers may not have been so smart. In the same way, Al-Ghazali's reconciliation of mysticism was to put it in an intermediate position. He was not for asceticism, which is actually denounced in the Quran. He was just for not being overly fond of material things. He was not someone who believed that mystical thinking by itself led to the truth, because he believed you have to use reason as well. That was his rebuttal, I guess, to, I can't remember which modern thinker it was who said, when man talks to God, it's prayer. When God talks to man, it's schizophrenia. If you think you have perceived the will of God, test it. Test it. Don't take it for granted. Anyway, so I think that what happened is that Muslims did lose track of the Quranic teachings about to study God's signs in the heavens and the earth. And by the way, it also added, and in your own selves, anticipating Kant, similar statement by Kant. So God's, as Al-Ghazali said about the builder of the house, you can believe that the house had an intelligent builder who designed it without saying that the design has to necessarily be in a particular way or even having to know all the details of the design. But the more you know about the universe, the more awed you can be by it. Einstein, who did not believe in the traditional God, but did believe in a creator, believed that there is a sense of mystery that the universe inspires. And that sense of awe is certainly something that, again, I hope I don't have to explain it to groups like yourself who seem to have an extremely rich schedule of star parties. So I think at this point I should stop and give you a chance to ask questions.
Well, let me ask the first one then. By the way, very well done, and thank you. You really sound like a Jesuit astronomer. I think that I agree with every word you said. With the Galileo affair, there was a notion that, and the out was, if you conflict with the understanding, the traditional understanding of revealed scripture, you can talk about it hypothetically as if you've got a mental model, and in fact, it's not physically real. Now, of course, Galileo thought that it was physically real, even though he had to waffle. Was that ever a factor? And of course, it gets very complicated with AI that will ultimately get so complicated we can't tease it apart. And even large models we use in astronomy, you know, we're back on the hypothetical. But was that ever a factor in Muslim thinking?
Well, thank you so much for that question, Kenny. You made me realize that there's something I really should have covered this, and somehow I got carried away and skipped over it. The question about why was the Galileo affair, I started by saying that, you know, it was an accident of Western history, and then I never explained what the accident was. There is a tendency to want to marry the metaphysics of your religious beliefs with the science of the time, at the time that is the formation of the church. In the case of the Roman Catholic Church, at the time that it became a power in the world, the Ptolemaic theory was the theory of how the universe operated. And the church saw a strong parallel between this physical model of a universe, in the words of Al-Ghazali, like an onion.
Right.
Layers, and their own view of hierarchy. So, you know, God is in the outermost heavens, the most supreme being. And then there's his son and the archangels and the angels, and you can identify all of these with the different layers of the Ptolemaic system as you come down to the earth. And on the earth, you have the Pope, and then you have the cardinals, and you have the archbishops, and you have the bishops, you have the parish priests, you have men, you have women, you have the animals, you have vegetables. And then you go into the earth and the layers of hell and so on, into the demons. And these two different ideas that shouldn't be married become married. They become identified with one another. And when a scientist comes along and says, actually, I don't think the universe is shaped like an onion, you're challenging the authority of the church. Not necessarily. Galileo was actually a believer.
Yes, sure. He was.
He had no problem with, you know, the fundamental teachings of religion, or even of the Catholic Church, except where they chose to make claims about the physical structure of the universe, where he had good evidence that they were wrong.
Yes.
Now, if you look at Al-Ghazali is quite pointed in the fact that it doesn't matter what the structure of the universe is. He says, scientists say, in his day even, scientists say it's like an onion. And he said, well, maybe it is. I'm not saying it is, and I'm not saying it isn't. I'm saying that whatever it is, that's the way God wanted it to be. And so if it's like an onion, it could have been otherwise. In other words, Aristotle's wrong. Everything is not the way it is because it could be no other way. It is the way it is because God made it that way. And if if our observations and sound theories say it's this way, fine, I got no problem. Just don't say that God had to make it that way, because he didn't. And this is, of course, the real issue. And like I said, it did not exist in the Muslim world. It wasn't just El-Biruni who said it doesn't matter. No one ever objected. On the other hand, when I did the second edition of this book, which is the one you held up, the first edition, what happened was I was approached by the Templeton Foundation, which gave me a grant to do a second edition on the condition that I would add a chapter to the so-called Quranic science, which has become a fad today among Muslims. Muslims, knowing that there's never been historically a problem between science and religion, are now trying to show that certain current scientific theories are actually in the Quran. And in that, they are making the same mistake the early church did. Because one thing we know about science is it's going to change. And if they convince people that a particular theory is supported by the Quran, what happens 100 years from now, or 200 years from now, or 500 years from now, when that theory is questioned by scientists? Are they going to say to those scientists, how dare you contradict the Quran? The Quran does make reference to the signs in the heavens and about particular things about it. And if we can interpret those references in such a way as to be consistent with scientific theory, fine. But I think it's not necessarily evidence of the proof of the Quran or the proof of the science, so much as God's ability to have a little fun with us and make a reference that we can think we see a parallel in. Anyway, I hope that answered the question.
Yes, I think so. Do we have one? We have a question in the chat. What is Islamic astronomers' view or explanation on the tradition that the prophet had split the moon in half? How is it interpreted today?
Yes. Okay.
Not my tradition. I don't understand the question.
I'll give you the background of the question because I actually refer to it in a chapter. I have a chapter called What the Prophets Saw in the Sky. And it discusses three things, astronomical phenomena that were discussed by the prophet. And one of them is this hadith. Now, I have to explain to you what a hadith is. As I think you know, or if you don't, I'll tell you, the Muslims' holy book is the Quran, which, as I said before, Muslims believe is God's word speaking to mankind through the prophet Muhammad, peace be upon him. But the Quran, in addition to the Quran, Muslims also look to a body of traditions called hadith. And these are the sayings of the prophet Muhammad or his companions. And they're not as reliable in the sense that the Quran was written down while the prophet was still alive and was canonized within 2 years of his death. Whereas these hadith were not written down in the prophet's time mostly, and were canonized a century or two after his death. And therefore, there's lots of room to question whether the hadith are even statements truly said by the prophet, let alone whether he was speaking, I'll steal a term from Roman Catholicism, ex cathedra, or whether he was just expressing a personal opinion, or even whether he said them at all, because after 150 years, it's quite a challenge to be sure that he said anything. Well, there is a hadith in which it is said that some companions were with the prophet standing on a hill, and the prophet pointed to the sky and said, "Look," and the moon was split in two. Now, the exegetes have claimed that this was a miracle performed in order to demonstrate the legitimacy of the prophethood of Muhammad. There's a problem with this. The problem is that an identical thing happened with some priests in England who looked up at the sky and saw the moon split in two and used the same wording. That event has now been understood by astronomers as being that the moon was being hit by a swarm of meteors And the support for this is that the same meteor swarm in a much more mild form hit the moon after we landed a astronaut on the moon and had set up seismic detectors, and you could feel the moonquakes as the meteors were hitting the moon. And it's the same meteor shower, just, not as strong now, many years later. In my book, I show that the cycle is such that the alleged time of the Prophet sighting could have also been the same phenomenon. If a chain of meteors hit the moon, caused a big rising of dust, so the otherwise full moon seemed to have a black break in it, that you might easily say the moon has been split in two. And phenomenologically, it would be an accurate statement. But to try to say from that it was physically split in two would be a bridge too far. So now, of course, I'm speaking for myself here, not for all astronomers, but I think that as a PhD astronomer who's entitled to make theories, say such things, that I do think that is a likely explanation of that hadith, assuming that the hadith is even accurate to start with. And I suspect it is, in the sense that it would be quite a coincidence that at the time of that meteor shower, the Prophet used the same words that were used centuries later by others in another land looking at the same thing.
Bob Ross.
Oh, incidentally, if I might, one of the other phenomenon that's referred to was an eclipse of the sun. And it's very interesting in terms of this question about, the relationship of religion and science, that the Prophet's son, S-O-N, Ibrahim, an infant, died on the day of a solar eclipse visible from Mecca. And many of the people started saying that the eclipse occurred because of the boy's death.
Wow.
And the Prophet gathered them together and said, the sun and the moon are signs of the sun and the moon are signs of God. They do not eclipse for the birth or the death of any human being.
I just have, before I read Bob Ross' question, I do have to relate, in case people don't know this. Remember Captain John Smith and the Pocahontas story? He was saved by the princess who said, to her father, don't cut his head off, or whatever he was going to do. Well, actually, Captain John Smith went to fight the Turks earlier, and he was captured by the Turks. And he's got a story about a Turkish princess who intervened. He's almost exactly the same way.
Wow.
He's very lucky, I suppose. Bob Roth says, I can understand his use of epicycles to describe the planetary movements. But how did Ptolemy resolve the phases of the moon, particularly when there is the issue of seeing the whole moon via Earthshine? Well,
First off, Ptolemy did use epicycles for the motion of the moon. That's just a fact. But then, as for the Earthshine question, I don't think, I don't know the answer for that, but I don't see why it would be a problem for him. He was concerned again with the position of the moon, and if the moon could be in a position where it was, not directly lit by the sun, but reflecting the Earth's light, that in no way questions his method of calculating the position of the moon. That remains the same. He may have wondered about it, but I doubt he would have seen it as any kind of criticism of his theory.
You mentioned that I'm not good at the names. Al-Biruni and the observatory, I think in Iran. I think that's where it was.
The Maragha Observatory?
Exactly.
Yeah.
And
that was at Tusi.
Al-Tusi. I'm sorry. Yeah, my history on this is very shaky. But historically, how long did that process, did they stay in operation? And obviously, this is a contentious part of the country, and the Huns are going to come sweeping through. But and what happened to all the observations and the data?
Okay. Well, I love that second question. I don't necessarily have the answer, but the first question, I don't actually know the answer to it. Pardon me while I do a quick search in case it's on the
Sorry.
internet. While that's going on, let me try to answer the second question. Oh, I'm sorry, I'm having a senior moment. The second question was
About the data. They would have had all these.
Oh, yeah, the data.
observations and-
Yeah, well, that's really interesting because there's reason to believe the data may still be extant. There is in the libraries in Syria, in Aleppo, enormous quantities of books from various periods in the history of the region, including scientific books that have never been cataloged. And I think it unfortunately, it remains for somebody to go in there and do the cataloging in order to find out what exactly is in there and what it can tell us about that very question.
Oh, interesting. We need an Owen Gingrich of this field.
Yeah, unfortunately, what we need is some Arab-speaking historians or scientists who are interested in pursuing this and can get funding to pursue it.
Funding. Yes.
So,
I think there's another question from Ehab. Did the requirement to pray 5 times daily help spur interest in astronomical calculations?
yes, the astronomers, were able to show how. Well, first, to answer this question, and maybe you're all familiar with this. If you know the difference between equal hours and unequal hours, then this will be redundant. But in the ways in which the day can be divided into 24 hours, you can divide it equally or unequally based on the position of the sun during the day as it makes shadow lengths, or just 24 equal periods as measured by a water clock or a sand clock or something like that, or in our era, a mechanical clock or an electronic clock in our era. The ability to transition from one method to another was something that the Islamic astronomers were interested in, and they did do calculations to show how the position of the sun and the lengths of shadows changed throughout the day, so that you could use either a sundial or you could use a mechanical clock or a water clock in order to tell what the prayer times were. But unfortunately, when mechanical clocks became really easy accessible, there was a bit of a backlash among the juristic class because they were afraid that some of their authority was being taken away by people who could just publish prayer tables as to what time the prayer was and not count on listening to the mu'adhin give the call from the minaret. But it never became a big deal the way it was. Not a Galileo affair style thing, but it was just a bit of conservative backlash. I see there's another question here by Sonny Adams. Do Muslims believe creation is in 6 days and 1 day is 1,000 years?
Oh, yeah, I see
Christians, or what? And is this a conflict? No, this is an example of where Muslims have been very readily willing to accept that some verses are a metaphor. And of course, they have to accept it because the Quran says so. There's a famous verse in which it says, some of what we tell you is a basic meaning, and some of what we tell you is allegory. And only those who wish to sow dissension will take one for the other and confuse the two. So although the Quran does say God created the earth in 6 days, there is no attempt to say it's 1,000 years or 1 billion years or whatever it is. It's taken that it's 6 phases of creation, and that the word day has to be taken metaphorically. And I'm not aware of any Muslim who, certainly no Muslim today who argues otherwise. So there's no similar fundamentalist movement in Islam. And if there was any Muslim at any time who argued that the days were 24-hour periods, they're not known to me. That doesn't mean they didn't exist.
Sonny, that's an interesting question. You know, there is one of the original postulators of the Big Bang was Father Lemaitre from, I think he was a Belgian priest, wasn't a Jesuit, but you know, the notion of the moment of creation and the expansion does have religious overtones, pretty strong ones, as a matter of fact. Yeah. But Father Lemaitre himself told the Pope, I think this Paul VI, he said, don't go around saying that there's any connection between the Big Bang and creation. They're different things.
Well, you know, I've always wondered why the fundamentalist Christians are so opposed to the Big Bang theory. If you have a theory here that is so close to the concept of let there be light.
Yeah.
What's the problem? The only problem, of course, is the time scale, that it's billions of years ago instead of 6,000 years ago. But
Is there any more? Were the Arab or let's say Islamic astronomers, Muslim astronomers, I'm not sure the right term, but because they're Persians.
You can say Muslim astronomers, or if you really want to be inclusive, because they weren't even all Muslims, you can say Islamicate.
Islamicate. Yeah, but once was there the heyday of their observations, which would have been done with big quadrants and things like that, with the advent of the telescope, and of course then Galileo finding Aristotle had made some serious mistakes and the model was coming apart. But did they pick up the telescope historically, or were they in a position to do so?
Well, actually, you know, the Ibn Haytham actually understood the principles of the telescope, and he had created similar devices using, again, globes of water. We take a small globe of water and a big globe of water as the eyepiece and the objective. So Muslims were familiar with it. And while I don't know of any smoking gun about the Leiden telescope makers being influenced by Islamic binoculars, I did note that in a famous movie came out a while ago, a version of Robin Hood, in which Robin Hood meets up with a Muslim who has a handheld telescope. They used it for those purposes. It was like a military instrument. It was Galileo's great achievement was to think about using it to look at the sky.
Yeah.
It was just never occurred to anybody, as far as we know, before Galileo, that you would see anything worthwhile by pointing it at the sky. And when you look at his arguments for the heliocentric theory, it is his telescopic observations that are the most powerful arguments. Because again, see, for example, when he looks at Venus, and I think this is the absolute strongest argument he gives, when he looks at Venus and says Venus has phases, and in fact, he knew it was so strong that he actually put it in code. In his book, The Starry Messenger, he doesn't say that Venus exhibits the same phases as the moon. He says something, I don't remember the exact words, but something about Cynthia and Luna, that obviously putting it so later generations would have no doubt he knew that this was the case, but not putting it in such simple language that his enemies could say, look what he's claiming.
I've got to look that up. But of course, there would have been problems with his telescope mechanism in convincing people who looked through the device, with all of its optical imperfections, that, what he said he was seeing, are you seeing the same thing? And they wouldn't necessarily be able to repeat the experiment.
Yeah, well, as a matter of fact, that was, the scientists who opposed Galileo get sort of a bad rap because it's not acknowledged that they had a case when they said, how can you trust these, optical instruments that are the same kind of thing you use in funhouse mirrors, at the carnival, that they're not a reliable source of scientific information. Now, in fact, they were, because it was repeatable. When he studied the orbits, for example, of the satellites of Jupiter, they moved in a pattern that that was repeatable, and therefore could not be dismissed as just imperfections in the telescope.
Yeah, Dave Decker wanted to follow up on your connection with, the transmission of knowledge to the West, Copernicus and so forth. And he said, do we know if Copernicus, Tycho Brahe, Kepler were aware of any Islamic science?
Well, we know for sure Copernicus knew about a Tusi. And Giordano Bruno, who was the one, Galileo was never burned at the stake, but Bruno was. And Bruno was familiar with Islamic, I'm going to call it cosmology. Bruno went further than Copernicus or Galileo, because Bruno did not just argue that the sun was the center of the solar system. He argued that the sun was neither the sun nor the earth were the center of the universe, and that the universe had no center, that everything was equal under God. That's a very Islamic notion that there's God and there's creation, and that's the big distinction. Anything else is the details.
Yeah, Bruno's a hard case, though, because he believed all kinds of crazy things that would have gotten him burned, and just about anybody who caught him, Catholic, Protestant, or whatnot.
Well, anyway, you can look up, more clearly what the connections are in different cases, although they're not all known. One of the things is, in the same way you look at the Muslim world today, advocates of democratic reform in the Muslim world do not always quote Western predecessors in support of their position, because it puts them suspect. And the same thing was true in the Middle Ages by the people being influenced by Muslim thought. They didn't always want to publicize the fact that they were getting these ideas from Muslims, because it only got them into bigger trouble. I'm sure aware that Thomas Aquinas, who definitely was aware of Muslim thinking, had his own problems with the church.
Yeah.
And
Oh, that's a good point. And of course, there was certainly a lot of philosophical interaction. Yeah, certainly in Spain. I mean, there's some ugliness there too.
yeah, because there was
a lot of intellectual competition.
Right.
As well as
Because of course that's where you had the strongest contact was in Spain, because once the Spaniards reconquered the Reconquista, they came into possession of the Muslim universities and all the knowledge contained therein, including, by the way, Aristotle himself, all of whose books in Greek, except for one, were lost to Europe, and they regained Aristotle by translating from the Arabic into Latin. That's what Aquinas referred to Averroes, Ibn Rushd, we call him. He referred to Averroes, he referred to Aristotle as the philosopher, and he referred to Averroes as the commentator, since his knowledge of Aristotle came through Averroes.
Oh, interesting. Yeah, just like there's a huge transmission of classical knowledge through the Greeks, through the Byzantines who preserved the Eastern Roman Empire. Right, and that's how the Muslims got their knowledge of
Western knowledge was from the Byzantines, as they conquered the eastern part of the Byzantine Empire. They hired the scholars to translate the works into Arabic.
Oh, no, okay, that's interesting. And that would have been 1453 or 450, something like that.
Actually, no, it goes back to the time of Mamun, because the 1453 is when they got as far as Constantinople.
Right. Oh, but so of course they were hacking away at the Byzantine
Right.
Empire. Oh yeah, certainly in Anatolia. Oh sure, yeah, you're right. Ah, incremental.
Yes, incremental. See, that's another thing. All of this is incremental. People talk about the scientific revolution as if somebody turned on a light switch. But what actually happened is the gradual progress that had been made in the Muslim world suddenly plunges into Europe like a tsunami and seems like a revolution, even though it took centuries for all these ideas to gradually accumulate.
Fascinating. Well, I don't want to monopolize your time, and I know it's getting late. Are there any more questions from the group? Any more going once, going twice? Okay.
Oh, I just have one thing. I was looking at the question about Brahe, Tycho Brahe, and people are not aware. You know that when Copernicus put forward his system, Brahe offered a compromise in
Right.
which he took the Copernican system and he switched the positions of the Earth and the Sun in order to maintain a geocentric system, but one that had all the advantages that Copernicus had, which, as I said, was Ibn Shatter's system. So actually, Tycho Brahe, inadvertently, as far as I know, recreated Ibn Shatter's theory.
Oh. Very, very well. Listen, thank you so much. This has been a wonderful talk and a great discussion. Thanks so much for coming and enlightening us on all these issues that, and history that, is not common knowledge for us.
All right,
So,
well, thank you all, and and buy my book.
okay, one copy. It's a very interesting book. It's not very long, and it's stuff that you don't know, which is always great. So thank you so much, Dr.
Thank
Ahmad.
you.
Bye-bye.
Good night.